We're dedicating this lesson to all the knowledgeable people. You are smarter than we are, and we bow to you. Grace called you guys nerds, which I think is completely inappropriate. Um, don't really appreciate that, but anyway. Okay, here we go. Nope, we're going to skip that. We're going to move to this. Gotta have your calculator today. All right. Do you want to hear my pre-rant? Yeah. Here's my pre-rant. Some of you might not figure out how to do this problem before the test, and that's a crying shame because you're going to have to know how to do it on the test. So you're going to want to figure out how to do this problem. This is a challenging problem. First time you work through it, you might be a little bit confused, but the more and more we do it, the better off you're going to be. You want to figure out how to work through these type of problems. This is critical. Otherwise, just take whatever grade you're expecting and subtract at least 1 from it, and that's what you're looking on the next test. The good news is that you're totally capable of doing it. As D. Weiland says, is there an element at which you as a teacher say, hey, did I teach it as well as I could have? Without a doubt, that was the first 2 years I taught it. But after now going over a couple of years, I'm very confident that without a doubt we can get plenty of people who can do this and do this correctly. You guys can all step up and get it done. Net change theorem says this. The integral from a to b of f prime of t dt is equal to f of b minus f of a. So basically, when you do the integral of a rate function, you get what we said yesterday was the total distance traveled, right? That's how we talked about total distance traveled. I'm sorry, not total distance traveled, the displacement. The displacement. Remember, I walked to the door and I walked back. We said the distance from me to the door was 15 feet. So if I walk to the door and back, what's my total displacement? 30. What's my try again. Sorry, I'm getting way ahead of myself. If I walk from me to the door and back, what is my displacement? 0. What's my total distance? 30. That's the difference. The displacement is this. If you want to know the distance would be the absolute value of the function, okay? So the absolute value. Now, as far as the mean value of a function, that's a little bit different. If you're looking at a function, you're trying to see what is the average value of the function at a given time, you do this. One over b minus a times the integral of a to b of f t dt. Now, you might be wondering, what the heck does that even mean? I'm going to draw a picture for you in a second so you can kind of understand what that means. Got it? Okay. I'm going to draw a function. This is f of t. The lowest height is here. The highest height is here, right? If you were to say what the average height of that function is between those two spots, where do you feel like it would be? You tell me when to stop. Right about there? So you're saying not quite halfway because there seems to be a lot of low spots, right? So you'd say, this is the average height. So if you take all the low spots, all the high spots, average them out together, that it's going to be about here. And I think that'll be right. So the actual average height of the function would be that 1 over b minus a. So you just take 1 over the width times the integral of the function over that region. That's how we figure out the average value of that function, okay? Average height, average value. See that? So let's try the application. And this is where it should really make sense from yesterday. It says, use your calculator for the following problems. The velocity of a car is modeled by this function. V of t is 20 sine of pi times t over 2 minus 1, where t is measured in hours, v is measured in miles per hour, and consider v of t over the interval 0 to 4, and let s of 0 equal 10. So I just want to clarify that v of t, what does the variable v stand for? Velocity. So that's the velocity of the car. S equals the position. So this piece here, S of 0 is equal to 10. What that means is that the position of the car at time equals 0 is 10 miles. Okay, you guys know what mile marker Albert Lee is on I-35? What mile marker we're at approximately? How many miles north of the Iowa border are we? 13. I drive it every day, so we're Owatonna, 41. Okay, so these are your mile markers where you're at. So basically, if you kind of related this to our position on the freeway, our position right now is say 13. Okay, and it would change as we drive north and south. Got that? Okay, and note that the derivative of the position function is the velocity function. And the derivative of the velocity function is the acceleration function. Good. Find the displacement of the car over the given time interval. So that gives us where it is now from where it started. So all I need to do is the displacement is just going to be the integral of the rate function. We're given the rate function, aren't we? So all we need to do is integral from 0 to 4 of v of t dt. No big deal, huh? Just for writing that on the AP Calculus exam, you get a couple points. You just need to know that finding the displacement is just this piece right here. That's it. You don't have to write the whole 20 sine of pi t over 2 minus 1 either. You just need to write v of t dt. But we're actually going to calculate that. We're going to use our calculator. Take it out. Let's type it in. I'm going to be smart about the graph as opposed to stupid about the graph. You good with that? All right. Anybody want to guess what the amplitude of this graph is? 20. The vertical shift is -1. So therefore, it's going to go between 19 and -21, right? So right now, I don't see it. I'm going to have to go to my x values, and I'm just going to go -25 to +25. Tick mark every 10. So you guys will press graph, and you won't see the graph. You get all angry. You got to sometimes adjust stuff and think about the actual function that you have. I'm getting the nasty look here. Well, you're going to see part of it, but you can't see the top, can you? Yeah, top gets cut off. Okay, so then the y minimum, whoops, I'm sorry, x. X is from just 0 to 4. So we're going to go, I'm just going to go -5 to +6. I'm definitely going to see everything then. It's the y value that we're going to change from. I'm going to go -25 to +25. That way I can see everything. A tick mark every 10. And y equals, I type that in. I go to my graph. And is that what your graph looks like? Y. Yours is nicer. Why? What's wrong with mine? You guys can figure it out. It's going to happen to you someday. Yeah, you're in degrees. So you go to radians. There you go. I'm teaching trig. Yeah. No. I do that because when it happens to you on the AP Calculus exam, you know to go to it. Okay? So here I go. I'm going to integrate from 0 to 4. Second, calculate number 7. And I go from 0 to 4. What do you get? -4. No. -4 what? Miles. Nope, because we're finding the displacement. It's displaced 4 miles to the left. So I want you guys to just think about this for a second. If it starts at 10 and it was displaced 4 units to the left, where is its position now? At 6. Does that make sense? Yeah. We all good? Question. No, if we could put S prime, the whole point here is that the prime thing means that this is the derivative. Okay, find the average velocity of the car over the given time interval. Yes. Find the average velocity over that time interval. Well, are we given the velocity function? Yes, we are. So to find the average value of the function, we do 1 over 4 times the integral 0 to 4 of v of t dt. Well, what is the integral from 0 to 4 v of t dt? So 1/4 times -4 is -1. Yes. The mean value or the average value of a function is 1 over the width of the interval times the integral from a to b of f of t dt. So the important thing is to identify what is the function you're trying to find the average value of. It says find the average velocity. So we are given the velocity function, aren't we? So we just put the velocity function there, 0 to 4, and what goes out here? 1 over b minus a. 1 over 4 minus 0. And since this was -4, 1/4 times -4. Now, what's our label? Miles per hour, because we're finding velocity, it says, so miles per hour. Find the total distance traveled by the car over the given time interval. Do you remember how distance is different than displacement? Exactly. So we would do the integral from 0 to 4 of the absolute value of v of t dt. Yes. Are we okay with that? So now I'm going to go to my calculator and I'm going to insert catalog absolute value. Put the absolute value around the whole piece. That way when I graph it, nothing should drop below the x-axis. Second, delete. Kind of fun to watch, isn't it? Second, calculate. Number 7. Going from 0 to 4. You notice my calculator, it takes a while. My calculator is dumber than yours. Okay, you got to go to 3 decimal places on the AP exam. So we're going 50.994 or 50.993. They'll accept either one. 50.993. And what is our label? miles. Now it says to find the position of the car at 2 hours and 4 hours. Now, please think about this. Okay? This is a question that always comes up. I asked Grace, and she said that if the car starts at 10 and it's displaced 4 units to the left, then what's the position of the car? 6. Everybody see that? In order to find position, you take the start plus the displacement. Oh, okay, it's no big deal. Let's do the easy one right away. Let's do the 4 hours one. So we'll do the 2 hours, and we'll do the 4 hours. Okay, so what's the start? 10 plus, and then the displacement, we did the integral from 0 to 4 of v of t dt. Right? Which is, no, close. That was 1/4 times that. The integral from 0 to 4 v of t dt is -4, so you come up with 6. So this one's located at 6 miles. At position 6 miles, that's where it's located. So can somebody tell me the expression I would write for the 2 hours one? You can do it. It's the same idea. Position equals start plus displacement. Plus integral 0 to 2 v of t dt. Do I know the integral 0 to 2? I don't know that yet. So I'm going to figure it out. I go back to my y equals. I have to get rid of the absolute value piece. That's the guy I have. What do I do now? What do I press? Second, calculate. Number 7. Now what? 0 to 2. And I have to add 10 to that, right? So equals 33.464 miles. What do you think so far? Not too bad? Okay. Let's make it slightly more challenging then. Find the acceleration of the car at 2 hours. Is this wondering the average acceleration or the instantaneous acceleration? Instantaneous is where we take derivative, right? So you said the derivative of the velocity function. Isn't this my velocity function? How do I find the derivative with my calculator? Second, calculate. 6. No. 0 to 2 would be an integral. What time are we trying to find the derivative at? At 2. It's just 2. So, pause. Here's what they would love to see right on the AP exam. We're wondering the acceleration at time 2. Don't you agree that that's equal to v prime of 2? Well, I don't want to go and take the derivative of that function. It's kind of ugly. So wouldn't you like to just do it the simple way? So I go second, calculate. Which one? Number 6. And I select time 2. -31.415. Miles per hour squared. Acceleration as a squared piece. Is that clear, folks? Because we're going to come back to that many, many times. This is one. For acceleration. All right. How is the next question different? Average acceleration. Okay. Here's where you guys get confused. Pay close attention. Mean value of a function, average value of a function. Are we given the velocity function or are we given the acceleration function? Velocity. So we can't use this formula for the average acceleration. We can't. If we want to find instantaneous rate of change, we use the derivative. What would you do if you wanted to find average rate of change? Derivative is instantaneous rate of change. Slope is average. So in order to calculate the average acceleration, we do v of 4 minus v of 0 over 4 minus 0. Just waiting for you to say it loud. Loud and proud. Now, let's look at our calculator and figure out how can we make this easy. Do we have the velocity function in our calculator? We do. How do we do v of 4? Second, calculate. Value. 4. What do you get? -1. Minus. Now, you don't have to press calculate again. You just press 0. And you get -1 divided by 4. So 0 miles per hour squared is the average acceleration. What do you think? Okay, the rest we get through on Monday. But Monday we have to be done with this stuff. So I'm going to give you a worksheet today that's going to, or you got it yesterday, didn't you? Take out your worksheet from yesterday. I'll show you what you should be working through for this guy. Okay, is this the next problem that you have? Okay. Okay, so I think you should be able to do the next 3 problems. So you're going to stop at the one that has the table. So when you get to the one that has a table, that's where you stop. Everybody got it? Okay, so you've got 10 minutes. I'd try to get one of these problems done and have it checked, okay? No, you can't have the worksheet.